Okay. In the previous video, we have constructed the circuit by using T flip-flop, right? So we wrote TA, TB, TC by comparing these A with A plus and B with B plus and C with C plus, and filled this TA, TB, TC. So to fill this table, we have referred this to table of T flip-flop. If both the inputs are same, like 0, 0, 1 and 0, the output will be 0, 0. If the input differs, the output will be 1. This is what, keeping this, we have filled this table, right? But when it comes to D flip-flop, so this is DC now. So I'm going with the D flip-flop, DC, DB, DA. Okay, we need to fill DC, DB, DA. So we need to refer D flip-flop route. Okay, so in case of D flip-flop, you know that. So this is a D flip-flop, right? If I'm passing 0, the output is 0. If I'm passing 1, the output is 1. Okay, so we can write it as D is equal to Q plus. Means, so whatever the value of for D, that will be the output. Getting? So if D value is 0, the out Q plus is 0. If D value is 1, the out Q plus is 1. That is what I returns. If you pass 0, you are going to get 0. If you pass 1, you are going to get 1. That's it. This is as simple as that. If you're passing 0, 0, 1, 1, 0, 0, 1, 1, or 0, 0, 1, 1, 0, 0, 1, 1, something like that. So 0 pass ಮಾಡಿದ್ರೆ 0 ಬರುತ್ತೆ, 1 pass ಮಾಡಿದ್ರೆ 1 ಬರುತ್ತೆ ಅಷ್ಟೇ D flip flop. So it's not complex. But in case of T flip flop, you need to compare present state with the next state, then you write T flip flop. So if present state and next state both are 0, so the output is 0. I mean, if present state, next state both are same, like 0, 0, 1, 1, then the output is 0 with respect to T flip flop. If the present state and next state differs, the output is 1 with respect to T flip flop. So in case of T flip flop, you are comparing present state and next state. Both columns you are supposed to take into consideration while you are writing the T. But when it comes to D flip flop, whatever might be the present state, forget this. Whatever might be the present state, forget this. So just write whatever the next state, whatever the data is here, just write as this one. So whatever the Q plus, that will be the D. That's it. 0, 1, 0, 1. So 0, 1, 0, 1. Here no need to take the present state into the consideration. So the same thing, whatever might be the present state, it's least bothered. Whatever you want to pass, that will be the output. 0 pass 0, 1 pass 1. It's simple. So now when you're supposed to fill DA, DB, DC, so should we take the present state into consideration? This is D flip flop, so we are least bothered about the present state. So while we filling TA, TB, TC, we compared A with A plus and wrote TA, B with B plus and wrote TB, and C with C plus and wrote TC. But that was T flip flop. But when it comes to D flip flop, so we are least bothered about this, whatever might be the present state. So the next state will be same as this thing. So whatever you written 1, 0, 0, the same thing. 0, 1, 1, this will be 0, 1, 1. 0, 0, 0, this will be 0, 0, 0. 1, 1, 1, so this will be 1, 1, 1. So don't case. 0, 1, 0, this will be 0, 1, 0. The same will be the same thing, because whatever you are writing here, that will be here. Whatever you are writing here, that will be here. So next state will be the D. That's it. Okay. So directly you can write whatever the data present here, directly write here. This is with respect to D flip flop. Now construct the KMF for this column, and this column, or this column, this column. Both are same now. This and this. Now both are same. So you are supposed to construct the KMF for this column, this column, this column. So the same here. So here they are written. This is the next state. So this is with respect to this table. So now D flip flop is same as this, right? So they have written this 3K map with respect to this A plus B plus C plus. So now this is same as D. Okay, so I'm referring this. Okay, so they have constructed a KMF for this column, this column, this column, which is same as this. Here it is. So they are not grouped. So let me group here like this. Okay, so we can group like this. Okay, then so this is acquired. Okay, so the equations for here is dA is the equation for this. You are going to get there are two pairs here for A plus. So two pairs you are going to get CA bar plus BA bar. If you take a common, you are going to get A bar plus C plus B. For B, for DB, you are going to get one quad and one pair, right? Yeah. This is one quad and one pair. For this quad, it is nothing but C. For this pair, this is nothing but B A bar. The same thing there written, C plus B A bar. This is the equation for B plus or DB. This is the equation for DA. Now DC. DC you got one quad. So both can cancel. This cancels. This is B bar. So sorry, C bar. No, this is B bar. Both can cancels. These two get cancels. This is B bar, right? The same thing. DC is B bar. So you got three equations. You got equation for DA and DB and DC. So what is DA? A bar into C plus B. C plus B means you are supposed to use OR gate. One connection is from C, one connection is from B. The output is connected to AND gate. So the other output will be A bar. This one. So then for this B plus C plus B A bar. So this is B A bar AND gate. The output of this is connected to input of OR gate C. This is DB. So this is B bar. That's it. This is how you are supposed to construct what is that? Construct a flip-flop. I mean the D construct a circuit diagram for the given sequence by using D flip-flop. Okay. Next we shall deal with how to construct the circuit by using SR flip-flop as well as JK flip-flop. Okay. The same sequence.